Hello everyone. Uh, let's wait for another 5 minutes so that everyone can join.
Hi, am I audible?
Yes, sir. We can hear you. Good morning.
Good morning.
Hello sir, good morning. We are
Yeah,
waiting
morning.
just another 5 minutes so that
No problem. No
people.
problem. Carry on. Nothing. The participants are mostly students.
We have faculty and students both, sir,
Okay.
and also PhD
Okay.
and postdocs also.
Okay. ఎందుకు మరి లైట్గా రాస్తుంది?
So, welcome everyone. We are here to celebrate the International Day of Zero Waste. Here we are ready to understand about a multi perspective on waste management in India. We have our esteemed speakers, and they'll be delivering different aspects of waste management in India and their experience and their learnings. Okay, first I would like to say a little about what is this International Day of Waste. Okay, This International Day of Zero Waste is a significant event adopted by United Nations General Assembly on December 14, 2022. We can all see that even though waste management is a very big issue, zero waste means like the waste which is going out of us should be always make sure we should make sure that it will be taken care by us only. So it's a crucial step towards sustainable future. So usually this event is held during March 30th. Today is the day, and we are here to celebrate this International Day of Zero Waste. And uh, on this International Day, let's us listen to the administrators, industrialists, and also social activists we have. So, our first speaker is Professor Chandrasekhar, and I would like to give a brief introduction about Sir. He is one of our esteemed professors from Civil Engineering Department at National Institute of Technology, Warangal, and now currently he is also the director of IIIT Nuzibid. He is an expert in area of water and wastewater and environmental impact assessment. Sir has lot of publications, and he is there in the academics for more than 20 years, and he is on the BOS of JNTUH, JNTUA, SVN, Kakatiya University, and also many governing bodies of engineering colleges. And he is also a editorial advisor board of analytical chemistry letters and also reviewer for several international journals. He has he has a lot of administration experience. He worked as a registrar in NIT Warangal, director of academics in Institute of Electronic Governance of Government of AP, and also he also worked as a head and training and placement officer for Government of AP and etc. He has lot of professional experience, and his expertise mainly stays in water sanitation and also environmental impact assessment. When we talk about his profile, I'm sure we need 1 hour to express his profile, but I would like to welcome him to this webinar. And sir, we are very happy to have you, sir, and we are very delighted to listen to you. Over to you, sir. Thank you so much.
Thank you, Chandana, for so many words. I am a simple man, okay, but by profession I am into academics, and all of you know when you are into academics you can't keep quiet. You have to be doing several things. So that's where I am. To start with today's what you call. Let me check where I am. Okay, I think is my screen visible?
Yes, sir.
Okay, is that fine?
Yes, sir. If you can do full
Yeah,
screen.
one
it
second,
will-
one
Yes.
second. I am into that.
I request all the participants to just switch on the video so that I can just take a photo. Thank you.
Okay, I think I will spend half an hour or maybe plus or minus 5 minutes talking about smart solutions in solid waste management. I think all of you know in the recent past, we have been applying a lot of smart applications in several fields of work because you start with medicine, you start with agriculture, you start with financial advisors or financial decisions or any kind of thing. Today, smart solutions are playing a big role. And why we have to invest our time and money in using these applications in solid waste management. I will give a brief introduction about why we have to look out for smart solutions. So if you look at, I mean, I don't know what are the diversity of the group I am having. Maybe if you look at some of the solid waste management concerns or challenges that we are facing today, rate of waste generation is one of the biggest challenge that we are facing for two reasons. One is because of increase in population, quantity of waste generated from urban areas is increasing day by day, year by year. I don't think we will end up with a solution where the rate of generation reduces. The other reason that we are trying to find a lot of increase in waste generation is the diversity of waste materials that we are using. I mean, the society has changed from traditional society to modern society. So what we do is we use a waste, all disposal materials. You want a kerchief, you have a napkin, a paper napkin, you want to have a coffee, you have a paper cup, you want to have a meal, you have a paper plate, all these are coming to be disposal items. Maybe like earlier days where we used to reuse the same material again, that tradition is going away. So generally, if you call this is a society where you find too many disposal items today. Then the other aspect that you should talk about is maybe 10 years back, 20 years back, if you look at what comes into the dustbin, maybe you had a handful of items, but today even your two hands full are not sufficient to count the diversity of materials that are thrown into the dustbin. Then the third aspect that we should really worry about is waste collection. So your cities are growing, population is growing, population density is growing. How do we handle the waste collection in a more efficient way? And if you really go and ask any municipal body or corporation, what is the first thing you want to get rid of? He will say the solid waste management. Please get get rid of this duty from my uh, array of duties. Then the other one, so when I said that there are different types of materials and these different type of materials had to be handled in different way. So the fourth aspect
Sir,
that we are facing lot of issues. Am
sir,
I clear?
yes, your screen, are you moving the slides, sir? It's not visible for us.
Not visible? First
Yeah.
introduction slide is not visible?
No, sir. It's in your first slide only. Maybe because you made full screen and you have to share full screen, sir. Share your full screen, then your slides will change, sir.
I will just wait. No, I have shared full screen.
You shared the PPT, sir, but
I can help you in this. When you
No,
do
no,
the
no, no.
share screen,
Wait,
can
wait,
you?
wait,
There
wait,
are
wait,
three
wait.
windows. Go to
Yeah,
the
wait.
extreme right.
That is not, I mean, I am not getting permission to share that. That share icon is not activated. Maybe I logged in from my office account.
sir, can you share the PPT to me, sir? I will
Yeah.
present from here. Meanwhile, I would like to welcome Professor Meenu. She is the head of CETSD. And CETSD is a department which works on Center for Emerging Technologies for Sustainable Development. We here in IIT Jodhpur, we work on any technologies for sustainable development, and I am happy to welcome Professor Meenu Chabra. She is the head of CETSD. Sir, you're sharing the screen.
I sent the PPT to you because that
Okay, sir.
icon which is saying share full screen, entire screen is not visible to me, is not activated.
I'm just seeing the PPT. Sir.
You got my PPT?
Yes, sir. Yes, sir. I'm just sharing it, sir.
Okay, fine. Okay, I think so. We have problems with waste segregation as we have diverse too many different waste materials and which require two different kinds of processing. When it comes to disposal. Then coming to processing, so when you are able to segregate the waste, then it comes, what do you do with the waste? No, you go back to this slide, previous slide. Yes. So what do you do with the waste? So whatever I want to do with the waste, there are a lot of processing techniques that are suitable for different kinds of waste. Say, for example, you require different processing for organic waste, require different processing techniques for the trash, or which you can burn paper, glass, plastic, or whatever. So the other challenge that we have is what processing technology, what method we have to use. Finally, ultimately, you talk about zero waste, but ultimately, where should it go? Even the smallest amount that you comes out, you should really think about disposal as well. Then, in addition to these concerns, the environmental concerns, because solid waste is always linked with health, health of the community, because it is always there embedded in the community. Then aesthetics, I mean, if you, nobody wants to see solid waste anywhere, and there are many countries which have found a solution to make sure that solid waste is not visible on the roads or on the open areas. Then, whatever practices that you develop, how sustainable are these? Are these sustainable for few years? How long they are sustainable is a big question. Then finally, to sum up all these, growth in population, change in lifestyles have made us land in this situation, and it is for us to find a solution. Though we are trying to find a solution for several years, but still we are not there. So approximately, if you really look at the waste generation rates, 5% annual increase in India, the processing cost is also increasing, and when it comes to collection, 40% of the uh, costs involved in solid waste management go for solid waste collection. So even that is a big question mark today. So if you really look at the Indian scenario, we only have 40% collection. The 60% is unaccounted, unauthorized. Where it goes, we don't know. I was in a committee for solid waste management of Hyderabad. During a committee, all of you know, as per 2016 solid waste management rules, it is mandatory that you segregate dry waste and wet waste and give it to the collector. But when many of them are giving it in the same bag or same dustbin, I was suggesting the municipal secretary that we should reject. Then he was very annoyed. Sir, we are now trying to increase the collection efficiency. First, let us deal with collection efficiency, then we will deal with the segregation aspect. So that is where we are. Next slide. So why should we indulge in using technology or smart solutions in solid waste management? Maybe if you look at some of the broader applications. You can use technology in improving the city sanitation and efficiency of solid waste management, especially route planning for garbage collection is first application that we have started using. Resource optimization. So that means that most of the resources that we get from, I mean, maybe in terms of vehicle resource or the human resource employed there or the recovery material as a resource, how do we optimize all these? Asset management, that means you have large fleet of vehicles, large, numbers of dustbins. How do we manage these assets? Efficient maintenance. See, I was telling you maintenance is the biggest task that the municipality faces. Then visibility of waste dustbins. So I think where should we put these dustbins is still a question mark. Though we are saying dustbin-free urban areas, but still you find lot of heaps of waste that is dumped in every corner of the city. So technology can improve in the efficiency of solid waste management and level of service. So why are we trying to integrate technology into solid waste management? Two main reasons. How do we increase efficiency and how do we improve the level of service? Because today everybody is concerned about service that is rendered by the municipality. Next slide. So what is smart waste management? So when we use too much of technology or all technological applications, then it becomes smart waste management. Smart waste management simply refers to any system that uses technology to make trash collection more efficient, cost effective, environmental friendly. So what are the things that we make use of? We make use of IoT, a monitoring technology, maybe how do you, maybe with a Wi-Fi or with sensor or whatever, real-time data access. All these are embedded finally to optimize waste collection and future innovation. Right, next. So what are smart bins? Maybe I think these are, I don't think we have seen them on the roads as of now, but very soon we will be seeing them. It recognizes the type of waste. Say you have 4 smart bin space and you have to put plastic in one, organic waste in one, paper in one, and different things. If you try to put a wrong waste in a wrong bin, it will not accept. So this is what is, that means segregation becomes very, very compulsory. That means you have to identify where you are putting what. Then sensors, image recognition and AI. So yeah, they are also embedded into the system where you put a sensor. Sensor may be for measuring the weight of the waste that you have put, or measuring the how whether the dustbin is full or half or whatever it is. Image recognition, especially when you are trying to look at what you call recycling and segregation of different ways, image recognition is very important. And all these are embedded, or artificial intelligence is being used for image recognition and all that. Then the smart bins, to optimize the space and to optimize the volume, it can be integrated with a compaction equipment. Optionally, you can have a shredding equipment to reduce the volume. For energy saving, you can use solar energy. So what do we do here? It monitors waste quantity, avoids overflows, and it leads to effective collection. And RFID tagging to identify centrally which dustbin is full, which has to be collected on a priority. And maybe there are ideas going in where you start pricing also with smart bin, where if you throw 1 kg of waste, you have to put a ATM card which will charge you immediately. User pays principle, right? So just to, if you look at the configuration of different types of smart bins that are being marketed today, So you try to throw something. So how does it recognize? You try to feed in all, say if you want to recognize a water bottle, plastic water bottle. So you have to standardize the bottle shape and material if you want to use this. So based on the shape, based on the material, it will try to send this plastic bottle into a separate channel where it can be uh, directed for recycling. Similarly, metal cans, similarly the other types of materials as well. So automatic sorting can be integrated into the collection system or the dustbin itself. Then compression, so to volume reduction. Then fill level indicator, so either in terms of volume or in terms of weight, you can always find out what is the status of the dustbin, maybe 60%, 70% full or 80% full. Then it gives a red indicator at the collection system. On a priority basis, the collection vehicle comes and picks up the waste from that particular dustbin. Then data processing in the cloud. So you have to integrate, data collection, data transfer, and GPS for effective utilization of these systems. Next slide. So one particular type of smart dustbin that is in market. So you have a sensor unit. So sensor unit, say tomorrow to to identify the user, there is a capture of photo. So who has done a mistake also, it can, just like you have who have violated traffic rules, you have a CC camera, a camera is also embedded there. You have a sensor unit, level indicator, green, yellow and red. Red means it is immediately it should be removed. After 3 successful crushes, sensor will start emitting the signal to the GIS server. So this is the technology that goes in there. Next. So this is that was one thing that I have shown. This is, a comprehensive unit where you can have 4 different types of materials that can be thrown into the dustbin, and maybe you can integrate, as I said, the who is the user and how much he has to pay also can be integrated into the system. Next. Then when it comes to the special kinds of waste, that is hazardous and e-waste and other kinds of thing, where does it go? Already in several countries, there are kiosks where you can take your e-waste or whatever. You can go there, put a card and throw the e-waste into the kiosk. And depending on the waste you are throwing, maybe sometimes you are even paid back. You get some revenue out of it. You generate some salvage value, or maybe if it requires advanced handling, then you will have to pay for it. Next. So conventional waste collection. So this is what we are using today, garbage conventional collection system, where we have a vehicle going into a specific route or specific collection of dustbins in one go. So what happens is it goes into road number 1, road number 2. Immaterial of the volume of the waste collected, it collects waste from road number 1 and road number 2. Maybe sometimes road number 1, road number 2, the waste that is dumped into the truck may be 50% full or less than 50%. Then what happens? It will make a trip to the MRF or the disposal facility without any purpose. So you are not optimizing the fleet, or you are not optimizing the truck for its daily use. So when we integrate the GPS system or smart systems, it will only collect immaterial of road number 1, road number 2, or road number 3. It will collect those waste from those dustbins where they are more than 50% full, or You can even give a command saying that it should collect waste from dustbins which are more than 80% full. So it will only, I mean, based on the programming that you embed into the system, it will tell you dustbin 1, dustbin 13, dustbin 26, dustbin 52, and it will give you the route as well to minimize the distance traveled by the truck. Thank you. Next. So these are some of the other smart solutions. Waste level alerts, I told you. Waste outside the dustbin. See, sometimes, many times, not sometimes, with the conventional practice, if you say most of the waste is outside the dustbin. So how do we control that? Waste overflows we can control. Pick bins, as I told you, they should be more than 50%, then only it will full, then only it will remove. Then there are some, say, dustbins which accept what you call wet waste. They try to release gases after 24 hours. So there also you can give a alert where it says this waste which has been dumped into the dustbin is more than 24 hours old. It will start releasing gases. So it will give a red light so that the trucks will be alerted to collect the waste from that. Then CC cameras, I told you today there are many violators of the waste. Who throw waste everywhere and anywhere. And today, as per solid waste management rules 2016, anybody can be fined rupees 500 for littering on the road. But we have not strictly implemented that for lack of monitoring techniques. Maybe you, in future, just like you are capturing traffic violations on CC camera, you will also capture solid waste violators on the CC camera and you will tag them for a fine. Next. So challenges and need for technology in waste solution, maybe why we have to do. So till now, our collection of garbage is mostly traditional part. Maybe you have people coming into the roads with autos or auto rickshaws or trucks and collecting the waste. Manual collection, it is impossible. It is very, very difficult to organize manual collection, in future, because you will not have people to do it. Waste collection routes are not optimized today. Even if you go to any big municipality today, they have only two methods. One is daily route. So he is given two routes, immaterial of the time or immaterial of the waste collected. He has to complete those two routes. Or sometimes he is given area method. So this is your area. You have to do waste collection in those areas. So what is the problem that we have? The efficiency is less. Utilization rate of the fleet is very low. So how way of manually monitoring is a very cumbersome process. As I told you today, how do you monitor? You have some supervisor or sanitary inspector who is monitoring that, but he really has no control over the system because he cannot go physically and watch them. So utilizes more human effort, time and cost. So that is the reason why we have to shift over to technology. Civic bodies give garbage collection contracts to private contractors. You have private entities who are on contract collecting the waste. So, but even that is not completely or effectively working. Next. So IoT, so anytime collection. So as I told you, it is not fixed schedule. It depends on the requirement. It is necessity based. So when you are, say your truck has a limited, a schedule for collection of the waste from dustbin. Say okay. So anytime connection, that means, depending upon the waste level in the dustbin, you have an alert. any place. So it is not a fixed route or fixed area. It depends on the necessity. Then anything, that means, as I was telling you, when you have gases, you have to collect the waste. When you have the, the other waste overflowing, you have to collect. Okay, next. So these are more system features. If you have to integrate the IoT and smart solutions into the traditional waste collection systems, that is stationary collection systems, or the other system that we have to. So what is that we have to do? Volume monitoring on real time. So real-time monitoring. So we have started using real-time monitoring in several other applications of environmental engineering, in industrial waste treatment, air pollution control, water quality management. So here also we have to talk about real-time monitoring, and especially volume, weight sensors, RFI tagging. So where is the dustbin? How uh, location based this thing. Ultrasonic sensors, so you can have different kinds of sensors as well. Auto compaction, so as all of us know, the density of solid waste is very less, so we can go up to 8 times compaction. Then you have, now to save energy, we can even integrate a panel to the dustbin where you can have solar energy being trapped for the required application. Waste collection optimization saves about 40 to 50% of the cost. CCTVs with facial recognition, automatic number plate recognition, red light violation detection systems. So these are all the things that can go into the collection systems. So data collection and organization. Always, if you look at any system which depends on automation, data collection and organization is very, very important, because many of the decisions that you take in later part of the application depend on the previous history, how you have handled earlier situation. Based on the data, you can always improve the decisions as you go by. Next. So this is the system overview. So sensing modules, you have the internet cloud, you have the data module, storage module, and decision-making module, and you have the field sensors, field dustbin and the vehicle where you have put the sensors. Next. So system functions. So basically sensing module. So it has a sensor, network interface, a battery, maybe battery or solar energy integration, storage module, a database where you make a database, distance calculation and optimization the distance, prediction algorithm. So always, if you recall our knowledge in predictions, prediction algorithm is always based on the earlier data and history of handling the earlier. User module, so waste data collection and the display. Next. So workflow of the smart bin systems. I think I will not spend much time on this. Next. So smart routing, so you can see unlike earlier cases, it is not moving in a specific route. It moves from one dustbin which is full to the other dustbin which is in the line based on minimal distance to the MRF, material recovery facility, or the processing facility. Next. So this is again, to take care of the traffic congestions and to take care of the traffic volumes on different roads. It can also give you the best route that is to be used by the collection vehicle to reach the MR. Next. Next. Here. So use of GPS and GIS is the basis for the entire smart solutions or the technology-based solutions in solid waste management. So GIS and GPS are the essential features of this. Next. So what would be the basic takeaways from the system? Reduction in the number of waste collection fleet required, reduction in number of waste bins required, savings on time and money, application of smart technologies in cities. But this is, when you apply, you have advantages, but later on I'll tell you what is the thing pulling back municipalities. Revenue generation, so you can generate revenue depending on pricing and depending on optimization of fleet and optimization of vehicles, all these. Maintaining healthy environment, so this is an intangible benefit. So it leads to better sanitation, better health. Dynamic routing, as I was telling you, this is the most prominent feature of the smart solutions. So ideal for highly populated regions varying in topography and climatic conditions. Next. So what are the limitations? The first limitation is the amount of investment that you have to spend on. Maybe I will show you what investment will go on in a particular city with with an example later on stage. And if you really look at municipalities, municipalities have no funds to invest on the system. So limited memory size. So many times, what should be the memory size that we have to use? Wireless technologies. So again, these are wireless technologies. Though we have a lot of access, but still that is a challenge in our country and in most developed countries. Increase in unemployment. So this is one thing that will say today, if you reduce number of sweepers or number of fleet in the municipality, I don't think any government can sustain the pressure. Skilled worker and management. So you are reducing the unskilled labor and you want requirement of skilled workers for managing this system. Modifications after installations are costly. So whenever you have a issue to deal with, you have to invest money again, and the system goes on requirement of upgradation every year or every month as you can go by. Not recommended for low populated regions. So where you can handle it with traditional system, maybe for villages and rural areas, you can't think about these solutions. Next. So I think I have some example to show you what will be the minimization of the cost and what will be the savings on money. This is one example of Greece. So you can see what is the existing system. Population is about 1 lakh. Total area is 6.5 square kilometers. Solid waste generation is 45,600 tons per year, so 1.3 kgs per capita per day. Then waste collection by different kinds of vehicles. You have 12,000 wheelie bins, 17 trucks of capacity 9 tons. So each mechanically 4 times a week. So the municipality empirically is divided into 15 sectors. That means collection zones. Even in India, we follow the same thing. Each of which is further divided into 2 subsectors. That means in total, there are 30 units. Next. So this is how they modified. So this is your red dots is your old one. Reallocation of bins and reallocation of routes is the green dots. And you see the optimal route system on the bottom left corner. Now it comes to savings. So you can see the old one, the earlier one, and the present one. So the distance was 296.5 kilometers. Now it was coming up to 287.5 kilometers. Savings was about 3%. Then when it comes to time, it was 18% savings on time. When it comes to velocity, the speed of the vehicle, it was again 18.5% savings. Fuel consumption 36, I mean 13, about 14%. Then cost efficiency was again 14%. Then carbon emissions was 12%, about 13%. So when they changed, when they modified only sectors and started implementing few of the smart solutions, the range of benefits that they had were, say, I mean, from 13% to 18%. So this was the example from Europe. Next. So what is the status of technology adoption in India? So maybe again, city of Ahmedabad, where they did a pilot project. Vehicle tracking systems and RFIDs were used for automating garbage collection. Mumbai also has the similar type of things, and uh, it was extended to 2,000 trucks and 5,000 garbage bins, not complete Mumbai, only greater Mumbai region. In New Delhi, also they have started working on it, but they have not implemented. Maybe in 2017, in the Andhra Pradesh, the Vijayawada, we also have started multiple tracking points for auto rickshaws. So manual tracking and monitoring is eliminated to find out to use the automatic tracking of the auto rickshaws. Next. So finally, what are the remarks? So if you want to have sustainable and smart technology for municipal waste management is becoming mandatory requirement for smart cities. I mean, even Government of India has listed a few cities as smart cities. So in future, they should be using these technologies. Smart systems can improve level of service, efficiency, and they can lead to economic and environmental benefits. So this is the biggest takeaway from there. Cost of integration and public awareness and acceptance are the challenges that we have. So what is the cost? What is the investment that has to go in? What is the acceptance of the public? So because if you say polluter pays, already I think many of us know that when you increase the rate of, I think most cities today pay for solid waste in slab rates. If we increase from 60 rupees to 100 rupees, there will be a lot of noise in the community, right? So it can be a long-term economic and environmental solution for dealing with solid waste management. Next. So these are the few examples. So I was telling you, I will show you an example. So San Francisco diverts 80% of its waste from landfills after implementing these smart solutions. Because if you really look at several countries, maybe compare two countries of different scenario, USA and Japan, both of them are in advanced countries. If you look at the focus or the emphasis that is given to what you call recovery, recycling, in Japan, it is maximum, whereas when it comes to USA, because they have a lot of land available, they give very little emphasis for recovery and reuse. So if you look at San Francisco, where they have implemented smart solutions, so they were able to divert 80% of the waste that was going earlier to landfill was going for recycling. And what was the investment that went on is $20 million, right? So the other example is South Korea, maybe even in some parts of Netherlands. You have truck-free, you have solid waste-free roads and you have dustbin-free cities. So what happens? Just like your wastewater collection system, you will have a pipeline where your waste is going into the pipeline and it is by suction, it goes to the material recovery facility. Just like wastewater is flowing in the underground drainage system, your solid waste is also going in the underground drainage system to the underground piping system to material recovery facility. Then coming to Amsterdam, I think Amsterdam is a beautiful city with a lot of canal networks in the city itself. They had a lot of legacy waste in their canals, which they cleared by putting floating dumpsters and waste streams where they could eliminate all the waste that was dumped into the canals earlier. And now they are contemplating the waste that can be dumped can be taken to MRF by autonomous boats where they don't require any energy. The flow will take, the dustbin will be flowing to the MRF, or waste from the dustbin will be flowing to the MRF in autonomous boats. That means designated boats. So they will not be requiring the what you call the trucks which use gas or petrol. So these are some of the things I wanted to share in this half an hour. I am not sure if I have taken more time or less time. I am open for a few questions if you have time.
Thank you so much for the information, sir. It was very helpful for us also to learn on it. There are few questions. Uh, One was there in the chat. Shailendra Singh, are you there? We can ask, or should I ask the question which is written? So Shailendra Singh asked.
Yes, yes, ma'am.
Yes.
Yes, ma'am. Sir, we are facing instrument side where most of students from this. In a dusty environment, malfunctioning is frequent.
Yeah,
So if we use the smart waste, then we can also chase the malfunction. And if solid waste and is not there, then it will show us that there is full of material.
yeah,
Like that.
that is one unreliability that is there. I mean, I'll give you best example. You must be using lot of toll gates, right? So only recently we have put all the toll gates with sensors which can track this car. But at least twice out of 10 times, you face a problem that either your vehicle or a vehicle in front of you is not able to scan the tag that is there and you are held up. So those system, what you call system challenges will be there, but they will be 10%, 15%, 20%, but not all of them. And maybe with experience, we can even try to overcome those.
No, sir. Means in toll gate area, there is a clean environment. But it's dustbin inside they are very dirty. And it is mixing of water and mud like that. So it is very, very
No, your
frequent
sensor
problem.
will not be having access to the waste. It will be placed in a place where it is not. I mean, the technology will not be that way. That you will not throw waste on the sensor. Sensor will be placed elsewhere. The technology that is used is either weight based or volume levels, which I mean, you have solution for that. But even with the solution, as you told, there can be reliability issues of the sensor, but what is contemplated will be 10%, 20%, not more than that.
But there is a Indian mentality problem, sir.
Sorry?
Yeah. Indian citizen mentality, we are trying early. So that is the most one required to take it.
That is why I told public awareness and acceptance is also an issue in this challenge in this implementation of smart solutions. Because if public damages it, nothing can work, right? So that is the other reason why what I was telling you was it is linked with integrated with CC camera is when you put so much investment, it should be having some monitoring as well. If somebody damages or indulges in some activity, he should be caught. Okay.
Yes, sir. But this identification is problem is remains. Okay, thank you, sir.
Thank you.
Thank you, Shailendra. Sir, there's a question in chat from Ananya Ghosh. Data storage cost, yes.
Yeah, all these are some of the things. See, when you shift from one system to the other system, these are the first things that we should talk about. Data storage, yes, it is a problem that, but we have to overcome, and there is a lot of revenue out of this system. See, if you look at two things, one is recycling recovery of resource, then the second thing is the environmental costs that are attached to this. So one is intangible, of course, but when you look at the benefits that you are deriving, definitely when you want to have data storage costs, I mean, even all these technology upgradation will be the biggest problem. Even if you look at your mobile, every 3 years, every 4 years, you will have to change your mobile because of various technological changes. So municipality, once it starts investing money on this, they should be prepared for going ahead of that. And if you remember our any of our applications, let's just say like water or wastewater or whatever, what we were paying earlier is much less when compared to what we are paying. And what we are paying for solid waste is not on par with what they are spending. So we'll have to pay more. And that is why I told the public, if they say, I told level of service should improve. When you should say level of service should improve, then your cost of service also will be attached to that. Say you look at Vande Bharat and normal train, you are accepting, right? Similar acceptance should be there for this as well.
So there's one more question from.
Can I add in something, Chandana, with your permission and with Sir's
Yeah,
permission, of course?
Yeah,
yeah.
go ahead.
So, sir, good morning. First of all, wonderful talk. It was
Thanks.
extremely refreshing to hear things from you and getting the academic perspective on solid waste management. So, I have one message from one of my friends from IIT Shilcha, Dr. Ringraj Kulkarni, one of your previous associates and junior. So, I shared the brochure of the event, and he asked me to pass on his regards and best wishes to you on this occasion. That is one thing. So, with your permission, I would like to add on the tipping fee, the user charges part. What you've been trying to highlight has, because I'm coming from the industry and had been into this business for almost last 10 years. So, one model Tamil Nadu has interestingly adopted as far as the user fee charges collection is concerned. That is, when you go for paying your house tax, automatically they will not be accepting your house tax unless and until you pay the MSW or solid waste management tax, which is 100 rupees per month. So 1200 rupees per year. Additionally, they are adding up alongside the house tax, and that's how you would be able to pay it. The same model, probably if we replicate on a pan-India basis, it would be easier to collect the user charges. Like for an example, I have been operating at Jamshedpur area. Jamshedpur area, around 5 ULBs, 400 tons per day I have been operating, my company had been operating. So their user fee is one of the crucial parts which we rely on as far as our revenues are concerned. So people, they are highly reluctant to pay, though the fee is somewhere around 30 to 50 within that slab based on the income group. Still people, they are highly reluctant to pay, and they are saying, when we are approaching them that this user fee model will be incorporated, they're like, we are not going to give the waste to you, we'll throw it out on the roadside, on the curbside. Again, that is leading to the illegal disposal or illegal dumping of waste. So that particular mindset, it is something I believe that it cannot be changed overnight. So rather than trying to force something onto the developers, if we can incorporate a model where they are paying, and on top of it we are just toppling up the amount, and that same amount is given back to the concessionaire, that would be more sustainable and feasible. But again, here, the conflict of interest situation should not be arising between the ULB and the concessionaire. Sometimes what happens, from my practical experience, I've been stating this thing, that the ULB receives the payment, and after receiving the payment, they get reluctant to pay the same amount back to the concessionaire. So end of the day, the service provider gets into the toss. I mean, their fate gets into the toss, whether they will get paid or not. And of course, in India, you know how state governments operate. So the payment cycle, the turnaround cycle is close to 3 to 6 months. So that means you do the work today, you invest your money today, and then you will get paid after 6 months. So a lot of crucial components are there involved, which actually makes it more riskier. But again, end of the day, somebody has to take the risk. Thank you. Thank you so much once again, sir.
Yeah. Very good thought process. Actually, when you said earlier in Warangal, each truck, I mean, the collection agency was charging 60 rupees per house for collection service per month. But what happened, like what you are saying, I will not give waste to you, I will throw it in one of the corner, maybe midnight dumping kind of thing happened. Then what happened, these waste collection trucks, they refuse to take waste from the houses because all the houses are not, they are giving service, but they are not getting payment back. So ultimately now it boils down to again yearly tax. Yearly tax 100 rupees per month is not very big money. 1200 rupees is no, I don't think they have. Maybe when you integrate, say, just like you are selling paper, plastic also people used to sell earlier, but today nobody bothers because nobody has time and patience. That is the attitude, right?
Yes, at the end of the day, that is the problem, because when they are actually littering on the roadside, as per my responsibility within the jurisdiction of the ULB, I supposed to make the city, keep the city clean. So
Yes.
I have to go and pick it up. So end of the day, even if they are not paying, even if the developers, the service, the end users, if they are not paying, I have to pull it and I have to give the treatment.
Yes.
So that's the irony of the whole situation.
So
Thank
there
you
was
again.
one question. Said decentralization or centralization, I think that was the question. See, actually, decentralization is one practice that is being practiced in Bangalore. I don't know if any of the participants are here. There are, I mean, decentralization of, I mean, they have a MRF in many colonies and it is working well. But the problem is when you put a MRF in a street and when it is having two houses in the street, all the people will complain this MRF should not be there, whether it is small or big. Nobody accepts MRF next to your house, right? So that is another issue that is we are facing. But decentralization is one solution that can work, but where is the, in urban area, where is the space for a decentralized facility? That is another question. So all these are, there is no specific thumb rule for handling solid waste. Ultimately, situation specific solution you have to arrive at and you have to implement that with the uh, acceptance of the public. That's the only thing that happens. Because we talk about public participation in several things, but I feel maximum public participation is required in solid waste management.
Yes, sir. And Omkar asked, we can use GIS systems.
Yeah,
Omkar,
GIS, GPS are very popular in this thing, right? All, I mean, when you want to use the truck routing and all that, you have to use GIS, GPS.
thank you so much, sir, for this talk and answering all the questions. And
Thank you.
sir,
Uh,
pipes.
by the way, Chandana was my one of the pet students, and she was one of the toppers in the class. That's why she wanted to tell so many things about me. Okay.
Yes, sir. And it's like even with so many years of experience, sir is so simple. He's like idol for us. Like, he's a very good academician we have seen, and he's our aim also to become like that.
Yeah, yeah.
Uh, so thank you
No,
so
you
much. And there's one more question,
become
sir.
better than
Pipes.
me. Yeah, okay. Okay. Piped solid waste. Yes, it is. It is already being in practice. Piped solution. Pneumatic collection. They call it as pneumatic collection, where you put a vacuum pump, and when you have the solid waste in the pipe, it is sucked. It is already in practice. As I told you, South Korea and even some parts of Netherlands. I don't remember that. It's a small city, not Amsterdam. It already has that system.
Yes, sir. Thank you. As you mentioned, India is changing. I can see that, like, as when you used to teach us solid waste, it was different. Now, when I'm listening to you, it's very different. So, as everyone were asking the questions about the cost, future, and everything, we can see many examples in India which has led us that change we can see, and I'm hoping that after 10 years we can see all these implemented in India. Thank you so much for the talk, sir. And I would like all the, again I'm asking, I would like all the participants to just switch on your camera so that I can just take a photo so that I can just keep it. I request others to switch on. Sushma, if you can take the picture, kindly take it. Sushma is one of my students. She is also working on waste management. And we have Professor Meenu.
Hi, madam.
He's a head of the center. So our participants have continuous questions to sir. I'll ask those questions again. We have another speakers from industry and
I
activists.
think you can take my number or mobile email ID from Chandana, and you can, I mean, any academic question you can, you are always welcome, right?
Yes. Thank you so much, sir. And our next speaker is Ananya Ghosh. He is an experienced development professional with 12 years of track record, and he's been there in government, public, and collaborations with financial institutes and donors. And he is skilled in ensuring timely project delivery, and also he has managed programs which has more than programs and projects which are more than like 5,000 crores validation, and he's been a part of India's waste management journey from 8 years. He's a civil engineer and also a NIT Silchars BTech graduate, and he has done the postgraduate management also, engineering project management as is from University of Leeds, and with experience in organizations like Satwa Consulting, Janvas, and also he's one of the government consultants from Odisha board. He is also is currently working to support Niti Aayog for NITI for states platform, and we are happy to have you, Ananya. The floor is yours.
Thanks, Chandana. I
हाँ
met Chandana.
फोन कर रहे थे मैं बीके झा बोल रहा हूँ
Thanks, Chandana. Chandana and I met a while back while she was visiting Odisha, and I was giving her a presentation on FSM in Odisha. Today's session, my session is on my experience of working on solid waste management in Odisha. My presentation will be a 180 from what Sir presented, from what Professor Chandrasekhar presented on solid waste management, which was smart. Mine is more low technology. I will just give me a second and I'll share my presentation.
During Ananya is presenting that, I would also like to welcome BK Jha sir. He's one of the environmental ecologists and socialists. Welcome, sir. It's very honor to have you here.
Please let me know once you can see my screen.
Yes, it's visible.
Okay. Okay. Thank you for inviting me for this session. I'll start. So basically, there are some things that I'll cover. One is what is basic municipal solid waste management. What are the components of municipal solid waste management? Municipal solid waste management can function only if some things function. And then I'll go into then I'll talk about a repository for waste management and much more. So an introduction to municipal solid waste management. So for us to understand what is solid waste management, we need to understand what is solid waste, and thereafter municipal solid waste as well. So solid waste is defined as any discarded solid fraction generated from domestic units, trade centers, commercial establishments, industries and agriculture institutions, public services and mining activities. When it comes to municipal solid waste, which is included in the SDG 11.6, It typically refers to the commercial and residential waste which is generated within the municipal and notified area, which is either in a solid or semi-solid form, minus the industrial hazardous waste, but including treated biomedical waste, right? And the safe management of all of this is what we would consider as solid waste management. What are the different components of municipal solid waste management? You have collection, you have conveyance, you have treatment and disposal, infra and operation and maintenance, including funding, capacity building and governance, ICBCC, monitoring and evaluation, enterprise engagement. I'll explain what I mean by enterprise engagement, and street sweeping. This is basically covers more or less 90%, 99, 95% of what is municipal solid waste management. The components in detail of municipal solid waste management. The first component is collection. Typically, as Sir was mentioning, only 60% of door-to-door collection is achieved. There are two ways in which we can look at collection. One is on the basis of the waste generator, which could be a household, or bulk waste generators. Bulk waste generators could be institutions. So, for example, there is a school, there is a hostel, there is a college. Those are bulk waste generators. Marketplaces are bulk waste generators. These are all different kinds of waste generators. Then you have the way in which waste is segregated, which will also, which is the most basic is wet waste and dry waste. Dry waste is further broken down into recyclable waste, non-recyclable waste, construction and demolition waste, you have biomedical waste, and you have e-waste. These are the typical different kinds of waste, although Ministry of Housing and Urban Development Affairs says that there are 14 kinds of waste, but you can broadly categorize them in these categories. Right? Once you have collected the waste, you need to take it from the generator to the treatment or disposal unit. That can happen through two routes. One is a traditional route, which will use a compactor. Typically, smaller urban local bodies have also used tractors, or you have basic dumpers. The current age version of a conveyance mechanism could be a battery operated vehicle. People are using tricycles, and there are push carts. 1 second I'll take here to explain why that in the new age there is a need for this, because what we are focusing on is on segregation at source. So when a household or bulk waste generator is segregating at the source, compactors and dumpers do not have a facility in which they can segregate the waste at the source and take it to the treatment unit, and they just take everything in one go. Whereas battery operated vehicles, tricycle, push carts can all have segments within their carrying units, which can be divided into dry waste and wet waste, and also have a separate unit for collection of biomedical waste. Typically at a household level, the biomedical waste which is generated includes sanitary napkins, it can include tampons, and so on and so forth. Similar with tricycles and push carts. So one special mention is required for carrying of e-waste. Now, e-waste is not something that we generate every day. So you can typically have, at least what used to happen in Odisha is that they would do a weekly collection of e-waste. Saturdays were typically dedicated for collection of e-waste, and the e-waste would then come to a treatment facility or an aggregation center. Then it comes to treatment. Now, treatment is divided here into 3 different categories. You have integrated solid waste treatment units, where you will treat both your dry waste and wet waste together. What Odisha has instead done is has gone for a more decentralized approach, something which someone asked in the previous question, in the previous session. They have created micro composting centers, and they have created material recovery facilities. The way it started is Odisha did a survey did a survey across 114 urban local bodies, where they checked what is the average generation of dry waste and wet waste in the urban local body. accordingly, they created MCCs and MRFs for collection of the same and treatment of the same. So while MRFs were being created, developed or set up, what would happen is they would designate a kabadi wala, a local kabadi wala, as an MRF, and would take all the recyclable waste to the MRF facility there. Composting center is basically a center where all the wet waste is coming in. It is being first segregated in case there is any dry waste coming in along with the wet waste, and then through the use of a locally generated enzyme which takes a week or so to generate, the MRF is composting all the wet waste, and thereafter it is transported to the local horticulture department or the local forest department and used as compost, right? Which is leading to zero waste as a result. However, this treats only two components of the waste that I was mentioning. It does not treat biomedical waste, for which incinerators are being set up to burn any biomedical waste which is coming in. There is e-waste disposers and cement factories. So what Government of India has come out with is a notification saying that any non-recyclable waste should typically go to cement factories, and cement factories have been identified which will take in all this non-recyclable waste. However, the challenge is that even in a state like Odisha, which is, say, of a medium size, there are only 3 cement factories. Conveying the or commuting the waste from the ULB to the cement factory is becoming a challenge. So what Odisha is trying to do is that if a local manufacturer of, say, pavers block can use that non-recyclable waste in creating pavers block, then it is doing that. E-waste is a different problem to tackle, because e-waste disposers or aggregators will typically not take in unless you supply them with 1 metric ton of waste. At a ULB level, on an average, especially smaller ULBs will not generate more than half a ton is actually too large a number, I said. Will not generate more than 5 kgs of waste in a week, right? So aggregating and sending it to an e-waste disposer becomes a challenge. So probably some policy decisions need to be taken in that regard on how to tackle e-waste. Construction and demolition waste. I don't think as a country we have come up with a solution. I think globally we have not really come up with a solution on how to handle construction and demolition waste other than recycling or reusing it. There is probably not a solution that exists for it. And finally, along with all of this, there is street sweeping which happens, which could be manual with the usage of people who are typically contractors who are deployed by the urban local bodies, or it could be mechanized. You buy a vehicle which comes and sweeps all your streets. This is regarding overall treatment. So this is the major chunk of solid waste management. However, there are other factors which come into solid waste management, which build into the system, without which solid waste management would not happen. So what are those? Capacity building and so the pillars that support solid waste management are capacity building and governance structures, roles and responsibilities. Who will do what? Are they enabled enough to take up that specific job is something that is required, that ULBs perform regularly. The state governments perform regularly. Government of India performs regularly. You have policies which are made, which comes under capacity building. You have strategies which are made. You have acts which are made, rules which are made. All of that comes under capacity building and governance structures. You have monitoring and evaluation mechanisms. So for example, what Sir was talking about would essentially fall under a lot of, it would fall under monitoring and evaluation through smart mechanisms. However, there are other mechanisms as well. There is manual feeding of data into say a phone, or even bookkeeping or register maintenance is a mechanism of monitoring and evaluation. Government of India on an annual basis does Swachh Sarvekshan, which is a mechanism for monitoring and evaluation. You give out awards and recognize ULBs and individuals who are performing well, that's a way to improve solid waste management or any other activity for that matter. I've mentioned something called enterprise engagement. Now, enterprise engagement is important because there are two mechanisms which are mostly followed in India. One is an urban local body onboards a private player to take care of its solid waste management. However, while in Odisha, what we experienced is there is a term that the principal secretary of Odisha now additional chief secretary of Odisha used to use, which was ghost waste. So typically, the private player would get paid on the quantity of waste that was being dumped at a dumping site or at a treatment plant, and the private player was taking more waste to the dumping site than the city was generating itself. So that is what he would consider, or he would call as ghost load. So Odisha did a 180 on that. Odisha went for community-based organizations to take up two parts of this. One is, I think, one is on information, education and communication along with behavior change. So what Odisha did is it took its women and transgender SHGs and said, our women and transgender SHGs will create a network of IEC, BCC across the urban local bodies. We will pay them 600 rupees per month to take up this activity. It is not a huge sum, but it is a small amount for the activity that they are taking up. And they would cover 8 households that one person would cover, which would ensure that there is more personal behavior change engagement, which helps in ensuring that there is segregation at source, and thereafter it ensures that the proper waste is reaching the site or the treatment unit, right? What Odisha government also said is that our conveyance, which is happening through battery operated vehicles, will be taken care of by the SHGs as well. In addition, they would also handle the micro composting centers and the MRFs. So the entire solid waste management system in Odisha, if you exclude e-waste and cement plants or any local treater, any local treatment unit for non-recyclable waste, if you exclude that part, everything else is being handled by women and transgender SHGs. Okay, so that's about the enterprise engagement. Then funding, right? Nothing works without money. So for solid waste management, most of the money is coming from the union government and the state governments. The ULB does generate some money, but it is typically not enough to even upkeep all the facilities that it is running. In addition, there could be funds under finance commission. So 15th Finance Commission or the upcoming 16th Finance Commission and state finance commissions across India are also funding parts of solid waste management. So, for example, a big push towards solid waste management happened somewhere around 94, 95, I think, when there was the 13th Finance Commission, which came out with the saying that if you do not allocate land for solid waste management, we will not allocate funds to you for towards the 15th Finance Commission, right? Which is a big push for waste management in the country. Information, education, and communication is something that I've already covered. Next, I will show you something which is Niti for State. This is something that I have recently worked. This was launched on the 7th of March by the Honorable Minister of MIT in Delhi. I'll just show you what it is. Basically, this is the website. It is a repository of best practices and policies. There are roughly 7,500 best practices on it and 5,000 policies on it. And there are about 1,000 data sets on it. What it can do is you can go to any of these sectors. Solid waste management is covered under water and wash, and you can directly go to that sector and look at all the material that is present on that sector. Right? So say about 920 best practices from across India, not just Odisha. and 521 policies across India are also mentioned there. When I say policies, it includes acts, schemes, programs that the government of India or the state governments could be running. You can also go and explore for a state. So if you want to say, for example, go and look at Rajasthan, you can just go to the state of Rajasthan and look at what is existing in Rajasthan. Rajasthan gets automatically selected, right? You could also just search for a policy or a best practice, and it will typically take you to that specific policy or a best practice. If it is existing, you can create further filters to narrow down your results. I wanted to show you this, and that's it from my side. And this is a QR code for my LinkedIn profile if you want to connect with me on LinkedIn and have any questions which I cannot answer during this session. You can ask me offline on LinkedIn. And that is it from me. I will conclude my presentation here. Thank you.
Thank you so much, Ananya, for keeping it short. Any questions from the participants? Maybe because of the time, maybe we can ask the questions in the chat. We can ask with the speakers later also. Now I would like to call our next speaker, Atun Roy. He is an ace in environmental engineer with a PhD from BITS Pilani. He is currently holds the position of Assistant General Manager for Technical Strategies and Planning at Cuba Bioenergy Private Limited. His professional journey has been marked by pivotal roles with esteemed organizations includes NARL, ISRO, and IL and FS Environment, Ramki Engineers, Bankabola, and Eco India Project Private Limited. He is a renowned leading researcher in waste management, water, and sanitation. He has expertise in many. He has.
Chandana, sorry for the interruption.
Yeah.
We can keep it short because we are running behind the schedule.
I don't know.
So better to keep it short and finish it.
Yeah. So welcome you, Atan, and the floor is yours.
Thank you so much, Chandana, for inviting me and all other dignitaries on the platform. A very good morning to one and all. So today I'm going to talk about the bioremediation and biomining. Before that, let me start sharing my screen. Chandana, could you please confirm if my screen is visible to everyone?
Yes, sir.
Yes.
Right, thank you. So as we all know, municipal solid waste, my former two speakers, they have highlighted and emphasized on how municipal solid waste is supposed to be treated, what is happening on the ground reality, and what are the best practices that we can actually adapt to make our future more sustainable and green. So I believe a very enough and ample amount of focus had been given towards that side. So that is why what is neglected till now, the part that the aspect that hasn't been touched. So probably I'll try to emphasize on that, which is legacy waste. So when municipal solid waste that is generated from our household on a day-to-day basis is not collected and treated, which is roughly dumped around an area which is in outskirts of your city or town, then that particular place is called a dump yard. And the waste which is accumulated over a period of time, that waste is then called as legacy waste. So what both of my former speakers had rightly identified, that in India, approximately, if I accumulate the rural and urban waste management, I mean waste generation in India, that is roughly 100 million tons per annum. If you typically talk about urban India, then it will be somewhere close to 62 million tons per annum, of which only 60% is being collected and only 20% is scientifically handled, I mean, which is getting properly treated, and then we facilitate resource recovery out of it. So approximately, we can see a potential around 60 to 80% is mismanaged. 60 to 80% of the waste, which is of 100 tons. So let's say roughly around 70 tons, even on an average, if I speak, 70 million tons of waste goes into the landfill or goes into the illegal dumping grounds every year. So now this waste which had been dumped previously, these dumping grounds, they are actually the breeding ground of various numerous kind of diseases, first of all. Second thing, they are affecting these dumping grounds, they are tangentially affecting all three atmospheric components, which is like, the gaseous environment, which is the atmosphere, lithosphere, which is soil, and hydrosphere, which is the water bodies, both surface as well as subsurface. So automatically there is a huge requirement that these dumping grounds, they need to be thoroughly remediated and they have to be eliminated, and the land has to be reclaimed back, because in a country like India, where land is one of the very crucial resources, where land is very scarce and in high demand, creating a dump ground is not at all a solution. That is one thing. Second thing is, dump grounds are filthier in the form of spreading diseases, spreading odor, spreading environmental contamination. So creating another dump ground is not at all our cup of tea at today's age. And our honorable NGT, National Green Tribunal, is completely against any creation and management of dump grounds on a pan-India basis. So all the dump grounds, whichever are operating at today's date, they're supposed to be completely scientifically remediated, and the land has to be reclaimed and hand over back for other sustainable, end uses. So how exactly this land reclamation can be done? How exactly the legacy waste can be treated? How exactly we can facilitate resource recovery out of it? So the answer is bioremediation and biomining. So as the name suggests, when I say biomining, automatically there's a picture in our mind gets reflected, which is mining. So mining is something which we always associate with excavation. So we have to excavate and take out the minerals from the earth crust. So basically here, the mineral is replaced with the help of useful byproduct, which could be refuse derived fuel, which could be compost, which could be other recyclables in the form of metal, glass, plastics, all these things. So that is why the term bio is actually incorporated with mining here. So, and the overall terminology is called biomining. So that means you excavate, but this excavation procedure also requires a remediation, because there is a contamination component associated with it. And this contamination can only be remediated with the help of biological solution. So that is why biomining and bioremediation, these two works parallel to each other. They are concomitant processes where first you do biomining, you excavate the waste, you loosen up the material. Second, you do bioremediation of the waste. So what is the difference between these two? What is the chronology of this two particular operation taking place? So the first operation is excavation. Now somebody may ask me, why excavation? So here I have actually depicted the milestone of different operations throughout the biomining process, where I have overall segregated the overall process into 6 different stages. So the first stage, what I call is preparatory stage. So during the preparatory stage, we try to understand what is the quantity of the waste that is actually there in the dump ground. So in terms of quantity, how to ascertain that, how to assess that? So for that, we generally have 2 methods. One is a total station based survey, which requires much more manual intervention, because you have to go and take levels at each of the, what should I say, like there are peaks. Dump ground is a complete, irregular topography. It does not have any typical geological shape. So automatically, when you are doing a total station survey, you need to climb up manually. You have to take the levels and you have to climb up the each and individual peaks and crusts. And then after that, you have to take level throughout the dump ground. And this is a very laborious and tedious task, because the dump grounds could be of acres. For an example, Delhi. Delhi has country's 3 major dump yards, which are Ghazipur, Balaswa, and Okla. And each of these dump yards, on an average, if I try to talk about, would be roughly holding around 70 lakh metric tons of waste. So the overall is somewhere between right now 1.8 to 2.1 lakh metric tons. So these dump grounds, on an average, the mean footprint of these dump grounds is somewhere close to 60 to 70 acres. So manually accessing 60 to 70 acres and doing survey is very laborious. So that is why the current approach that we actually follow is DGPS survey, which is performed with the help of a drone. And with the help of a drone, we fly a drone. With the help of a drone, we take the levels of different peaks and crusts. And then after that, we actually run one digital simulation. With the help of the elevation model and terrain model, We remove all other unwanted and foreign objects which are there within the dump ground. Let's say a building, it could be a building, it could be any trees and shrubs. We remove and eliminate all of those things, and then after that we actually ascertain what is the exact volume of the waste. But generally when we talk about the solid waste, we always talk about the weight of the waste, not the volume. We never ascertain the waste by its volume. Why so? Somebody may ask me, why so? The answer is the volume of the waste will vary based on the moisture content. If the moisture content is higher, automatically it will become bulkier in nature, and if the moisture content is lower, it will shrink in volume. So volume is not a very reliable method when we are ascertaining or quantifying solid waste. That is why we often rely on weight. So weight is nothing but volume divided by density. So typically Indian MSW, municipal solid waste, has a density somewhere between 0.6 to 0.7 gram per cc. And when you talk about legacy waste, which is typically the target waste for biomining, it has a density somewhere between 0.8 to 1 gram per cc. So someone might ask me why exactly legacy waste is more heavier when compared to municipal solid waste. Because legacy waste, as the definition says, legacy, that means the waste had been prolonged dumped on a particular ground. So due to this prolonged dumping, one layer was dumped on the top of the other layer, and the waste got sandwiched. Once the waste got sandwiched, automatically because of the weight of the waste, there was a compaction happening during the prolonged tenure. And once the waste is compacted, automatically the density is supposed to increase. That is one thing. The second level of action, what was happening throughout the tenure, is the rack picker movement in every Indian dump yard. That is something like an uncontrolled process, which we don't have a restriction or particular regulated lot over it. So because of removal of the recyclables and value-added items, which are typically lower in terms of density. If you talk about recyclables and RDF, it has a overall or mean density of somewhere around 0.3 to 0.4 gram per cc. Whereas the combined wet and dry waste has a combined density of 0.6 to 0.7, as I told you earlier. So when the recyclables are removed, automatically what we are left with mostly the organic waste and the inert in the dump yard. So that is why legacy waste is having a higher density than regular municipal solid waste, or fresh waste, how we call it, the fresh municipal solid waste, which is generated on a day-to-day basis. So what we do is we do sample collection. How the sample collection is now performed: we actually excavate throughout the length of the dump yard. We actually excavate multiple number of holes, and then across the depths, 3 different depths, and at least 15 to 20 different sampling ports across the length. And then after that, we collect somewhere close to 200 kilos of legacy waste sample. We mix it thoroughly, and then we use quadratic elimination method, through which the samples placed diagonal opposite to each other, they are eliminated, they are removed, and then they are mixed again. And that is how from 200 kgs we actually minimize it down to somewhere around 10 kgs, and that 10 kg sample is actually utilized for further ascertaining the composition of the waste and ascertaining what is the density of the waste. These two are very important. Now when I say composition, I mean what is the percentage of possible refuse derived fuel in it, what is the percentage of compostable fraction in it, what is the percentage of inert fraction in it, what is the percentage of recyclable in it. So in a lab test, from this 10 kg we derive it, that how much each of these components are there, and then based on that we actually make a decision what kind of machinery and what kind of approach we need to go ahead with. The second thing what we do is we wanted to understand what is the stage of biodegradability of the legacy waste, because fresh waste is completely non-degraded in nature. It's supposed to be digested through a proper biological digestion mechanism, whereas legacy waste had been getting dumped at that particular location, let's say from a few months to for last few years. So automatically, because of the inherent microbes that is present in the waste, there's a high possibility that the waste must have undergone partial to complete digestion. So how do we assess that? So as per the CPCB Legacy Waste Management Manual 2019, there's a beautiful test method which is called a seed test. So any seed you can procure from the market, you can take the waste and you can actually implant the seed in the waste, and you can start watering it for 7 consecutive days. If you see this seed is actually getting bloomed, if you see this sprouting is happening, So that means the waste is digested in nature, and in order to be double sure that it is 100% digested, we do windrow composting of the waste only for 7 days. If we see that there is no sprouting, there is nothing coming out, there is nothing rooting out, so then automatically the digestion period gets increased from 1 week to 3 to 4 weeks. And now how we decide the waste is further digested? For that, there's a lab test which is called starch iodine test, or we call it maturity test in colloquial language. So we digest the waste, and then with the help of acid, and then post that we add iodine into it, and then based on the color change, what color it is depicting, whether it's golden yellow or whether it's brownish blue, or whether it's completely black in nature, we actually come to a conclusion. If it is golden yellow, that means the waste is completely digested, and it can be further screened up with the help of mechanical screening equipment. If the waste is not digested or partially digested, then the color will be somewhere around brown to green or bluish. If the waste is completely not at all fermented, not at all digested, then the color will be somewhere around dark blue to black. So these are all preparatory stage. Once the preparatory stage gets over, we're supposed to get into the consensus, because all of these waste management projects, they are categorized under red category by Pollution Control Board. So now somebody might ask me, what is red category? So when we do any project, all the kinds of project, irrespective of its nature, they are categorized into 4 categories by Pollution Control Board: white, green, orange, and red. So white depicts the lowest amount of pollution possible, whereas red depicts the highest amount of polluting projects. So unfortunately, solid waste management, liquid waste management, FSM, all these projects, they are categorized under red category. That means these particular projects, they have a potential to pollute the environment highest if they are not handled properly. So PCB consents, Pollution Control Board consents is a must. So first we go for consent for establishment, and then we install all our machineries. Machineries generally include the transformer to power the waste. Typically we rely on electrical power, because if we use diesel machineries, automatically the amount of emission it is going to emit, that has a negative footprint. The carbon footprint of the overall project is again going to be enlarged like anything. So that is why we mostly rely on electricity powered machines, which are roughly like trommels or hybrid screening machines. And then post that, we go for air density separation, we go for shredders, we go for baling machines. So I'll be showing you all those pictures, how the this process byproduct, how they look like, what are all the different fractions. And then weighing, of course, it's one of the crucial elements. We have to weigh the waste, because all of these activities, whatever we perform, that is on a chargeable basis. We charge the urban local body based on the amount of waste is supposed to be processed. The rate for biomining, it varies somewhere from 350 rupees a ton to as high as 1200 rupees a ton, based on where exactly the municipal body is located, how far are the cement industries located from the urban local body, as rightly identified by Mr. Ghosh, that cement industries are one of the biggest challenges for RDF disposal, because the supply here is more, the demand is less. The amount of cement industries which can take RDF as its source of energy is comparatively lesser when compared to the RDF production in India. So that is why typically the RDF that is sourced from fresh waste or from biomining, it travels somewhere between on an average from 50 kilometers to 800 kilometers on a single side hauling distance in India. So based on the distance that RDF is supposed to travel, the biomining rate varies. So if I try to give you an example of Delhi, so Delhi Ghazipur biomining project we have been handling. So this project, the rate of tipping fee which we are charging to the will be somewhere, I cannot give you the exact rate because of the confidentiality issue, but you can say it varies somewhere between 700 to 800 rupees a ton. Okay, and then biomining is performed in patches. So let's say the overall area is 100 acres. So the first target, what we try to achieve is 30% of the clearance of the land parcel. So that means I'll target a particular area, what I want to clear first. And then after that, I'll clear the entire area. I'll go till the depth where I actually hit the hard ground or the red soil, where there is no trace of any legacy waste. And once the depth is achieved, after that, there will be an initial survey, which will be performed in presence of all the ULB officials, the independent engineering authority, the project management consultant. And once all the stakeholders, they agree that, this particular depth is going to be common across the entire dumping ground, Then based on that, we will excavate through that particular until that particular depth throughout the dumping ground, and then we start recovering the land in bits and pieces, in parcels. So 30%, and then we go for like 55% of the reclamation. Then we go for 80%, and then we go for 100%. That is how the milestone is divided. And during this process, land clearance, it parallelly supported with screening. Before screening, of course, composting supposed to be done. The material supposed to have a free flow, and then only it can be fed into the screening machine. And then post screening, it gets separated into 4 or 5 fraction. One is compost or good earth or manure, howsoever you want to place it. Second one is inert. The third one is refuse derived fuel, and the fourth one is C&D waste, the construction and demolition debris, and the fourth one is the recyclable. So these are all the components that you can actually end up recovering from any biomining project, and proper or pertinent disposal of these components are also pretty important. So here I have tried to depict, how exactly the overall timeline works. So the first is excavation and micropiling. This process, it goes for about 10 days if I try to understand in terms of the timeline. Then windrow composting. Typically, windrow composting takes somewhere around 20 days. We do it with the help of effective microorganism culture. So we take the overall waste, we excavate, we loosen up the material, and then we form the waste in the form of a trapezoidal heap. It has a height restriction of 2.5 to 3 meters. And then post that, we apply bioculture, effective microorganism culture on it, so that the organic material, whatever is semi-fermented or non-fermented in nature, that can be further digested. And then we give periodic turning, which typically varies between 4 days. Once in 4 days to once in 7 days, based on the climatic condition. During monsoon, the frequency comes down to 3 to 4 days, and during summer, during winter, it goes as high as 7 days. And then post that, it is fed into a machine which is meant for mechanical size segregation, which can be a trommel, which can be a mobile screening machine. And then post segregation of different fraction, there are intended application for each of these byproduct prescribed in CPCB manual 2019. I'll come to those things. So now if I try to give you the marks of this,
sorry, but little time.
Just 5 more minutes can I take? 3 to 5 minutes. I'll try to restrict it within 3 to 5 minutes. So compost is typically 45% of the overall material recovered. RDF is somewhere around 20 to 25%. C&D and inert, cumulatively, they contribute somewhere around 35%, where C&D is 15% and inert is 20%. So compost, it can be used for any green belt development. There are problems with each of these byproducts, because compost is most of the time, which is sourced from legacy waste, it is infested with inert. RDF is also contaminated with soil, which actually contributes to higher ash generation when RDF is burnt. And inert, it is generally meant for landfill as per CPCB manual. But again, inert, if it is properly decontaminated, if there is no microbiological contamination, automatically this inert can be used for different construction related activities. C&D waste, of course, if it is crushed, it can be converted into as per the regular stream of recycling, it can be converted into fine aggregate and coarse aggregate, which is typically sand and stone, and it can be sold into the open market. I'll probably skip this particular slide so you can see different activities which is happening. So here you can see wave bridge installation is going on. Here you can see from the excavator is giving turning on the windrow heap, and then it is loading the material into a tractor so that the waste can be further fed into this mobile screening machine, which is manufactured by a company called Terex. The machine name is Warrior 1200. And you can see 3 different conveyor belts coming out post screening. So one conveyor belt, it is storing only the mud fraction, the compost fraction. The other one is inert, which is on the other side. And then this one is the RDF. You can see the drone survey is going on here in order to ascertain or quantify the overall quantity of waste. Few other photographs can be seen here. Total station survey photograph also can be seen. You can see me collecting samples of legacy waste in order to understand its composition. Further, you can see the effective microorganism spraying is going on the windrow heaps. These are the windrow heaps. Those were formed. Typical wave bridge slip, how exactly it's supposed to look like. This is the wave bridge installed at the site. You can see the excavation and material loading into the Hiva tipper, and then material is fed into the mobile screening machine. So thank you so much for everyone's patience listening. And I'm open to the forum for any question. There are a lot of challenges associated with each of these activities in terms of quality, in terms of quantity, in terms of where exactly it's supposed to be disposed. But again, end of the day, we require support. At today's date, what I feel like the primary or the pertinent challenge in terms of biomining is the RDF disposal. Because as I told earlier, the supply is tremendous, humongous, whereas the consumption, the players that can consume is very limited. So that is why RDF needs to travel somewhere around 50 to 800, as high as 800 kilometers on a single side hauling distance. So traveling 800 kilometers again is a carbon positive phenomena. So we can try to increase the number of waste to energy plants where this RDF can be harvested in the form of energy. We can try to encourage more cement industries to come up with, alternate boilers where this alternate fuels and RDF can be energy harvested. Thank you. Thank you so much once again for your patience listening.
Yeah, thank you, Arjun. It was very interesting. Swati has a question. Kindly go ahead, Swati.
मुझे ये पूछना था कि अगर जो वो आजकल प्लास्टिक्स आ रहे हैं ना कि कंपोस्टेबल प्लास्टिक्स हैं, तो उसको कितना टाइम लगता है अगर हम उसको बायो एंजाइम स्प्रे करके रखें कंपोस्टिंग के लिए?
Okay, so basically they are made of PBAT and PLA. So PLA stands for polylactic acid. So इसका जो composition है वो biodegradable है for sure. But end of the day, what micron you're using. So typically the bags that you are getting in the market, this biodegradable plastic bag, this stands somewhere between 30 micron to as high as 100 micron. And 50 micron is the typical bag size that we use, which is medium bag size. And 50 micron can accommodate somewhere around 1.5 to 2 kilo waste, which is roughly around, if you have a family of 4, and if you are generating on an average 400 grams per person per day, so 1.6 kg is your per day generation, which can be handled by a 50 micron bag. This 50 micron bag, typically through windrow composting method with the help of effective microorganism culture, it takes somewhere between 15 to 20 days. And CPET, whenever if you're a manufacturer, of these bags, there's an agency, a CSIR agency called CPET. So CPET biodegradability certificate is highly required before you start selling the product into the market. So once you start manufacturing your bag has to be given to CPET. CPET will do this biodegradation study, and then based on that, they will issue a certificate that your bag can be biodegraded within so and so period. And the highest threshold for this period is 30 days.
Thank you, Arjun.
Thank you.
I have one question.
Yes, please, sir.
Yeah, these days in these multi-storied complexes, they are putting a what you call composting unit, turnkey, or this kind of thing. How effective are these over time? I am only getting, I mean, as I am a CESD member, they come to us with a proposal that we are handling waste this way. But over time, how are they working? They are putting in the basement. Are they not leading to foul gases and all these? I don't know what's the...
See, coincidentally, sir, I have a very pertinent experience related to the question that you are asking. So we are one of the pioneers. Cube Bio is one of the pioneers of waste management at a community level. We have started providing service for gated communities in Hyderabad. And already we are serving 2 communities by very prominent infrastructure developers in and around Telangana. So the problem there is mostly this community-based, gated community-based approach is high-rate organic composters. There are multiple manufacturing companies which are all making a high-rate organic composter. The capacity varies somewhere between 50 kg per day to as high as 2000 kg per day. But these are all heat-based treatment system. So that means it's a regulated, it's like, aerated static pile composting, but in more controlled environment. So you have a contained system. It's a controlled environment where you can regulate the temperature, where you can supply heat in order to maximize the temperature. Let's say for composting, the optimum temperature that you require is 60 degrees Celsius. So it will maintain 60 degrees throughout the time, and then it will keep on supplying aeration, but that comes at a cost. You require a lot of electricity in order to maintain that atmosphere. That is one thing. Second thing is this treatment facilities of high-rate organic composter. For an example, Waste to Gold is one of the companies which manufactures this high-rate organic composter, and you will find many of those companies in the market. If you search on Google, high rate organic composter, you will find plenty of those companies. They are claiming our treatment cycle is somewhere between 48 hours to 72 hours. But that's a marketing gimmick. What they're not revealing is they are doing only the pre-processing. So what they have is one organic pulverizer or shredder, so that they will micronize the size so that the surface area will get increased. And then they will incorporate one bioenzyme or effective microorganism culture in it, and they will maintain the atmosphere, which will maximize the composting period. But 3 days, never ever anywhere in the world composting can happen. The composting typical period is minimum 15 days, even if you accelerate, even if you give the best atmosphere.
Atun, my question was not about the technology, how effective they are and what are the problems. I mean, over a period of time, are they successful or?
Not at all, sir. Not at all, because the energy consumption is extremely high. Second thing, the vulnerability of the machine. I have studied at least 12 to 15 communities across Hyderabad where this machine typically stops functioning somewhere between 3 to 6 months post procurement. So the vulnerability of the machine is very high. Second thing, it is only pre-processing. So the efficacy, when you get the compost, it is somewhere around semi-fermented. It is not at all converted into compost. As far as the foul smell is concerned, as because it is a controlled environment, the foul smell will not be very severe that it will affect. Leachate generation is something these machines, they can't tackle. And if you have a lot of leaves, the other problem here is the lignin content, because these gated communities, they have a lot of green belt, right? 33% green belt is a mandate as per the NGT norm. So when you have a lot of green belt, you have to do a lot of pruning, and pruning activities leads to a lot of trees and branch. So unfortunately, they mix up these trees, the plants and leaves alongside the other compostable material, and it goes into this high rate composter. It is very high in lignin content. So when you start digesting it, it cannot be digested within the 3 days period. So the quality of compost you get is somewhere around, if I try to give a rating, it is about 2.5 out of 5. And smell is not there for sure. Like 80% odor can be removed. Leachate problem is surely there. Leachate dips up from the bottom of the machine in majority of the cases when the waste is highly, intrigued with the moisture content. And the third thing is the vulnerability of the machine. So this is not at all a successful model. But we don't have alternate to it, unfortunately, because of the space constraint.
Thank you, Atun. Thank you so much. Maybe we can take the questions in the end also again. There's one more speaker. Her name is Preeti Rao. She is the president of BAI and national president of WICC. She has done a postgraduate in marketing from Bangalore University and also a founder and driver force from Soil and Soul Foundation and Bioenzyme Enterprises Academy, with her 20 years of experience in the bioenzyme. And she's also a social activist, as I also know her personally. She has done lot of even aerodio modelings and also use the bioenzymes for many other process. We welcome you, Preeti, and the floor is yours.
Thank you. Thank you, Chandana. And and I hope my window is open.
Yes, Preeti.
Yeah,
Yes.
so I would just, without taking much time, I would just like to go through fast whatever thing has to be spoken. Now, I would like to focus more on the food waste and bioenzyme, how bioenzyme can be effective in managing the food waste what we have today. Now, okay, so can you change? Can you see my screen
Yes,
changing,
yes,
right?
yes.
Okay. See the enzyme, bioenzyme is actually initially named as a garbage enzyme, and it is still addressed as garbage enzyme. The reason is it is made from the things what we discard from home. So it could be a cooked food or uncooked food. Now, the challenges what we have, what I've been listening to the previous speakers as well, is the methane what we generate from the landfill or in the food waste, in a different ways the methanes are generated, which is actually causing one of the major reason for the global warming or the greenhouse effect. Now, and methane is definitely 25% higher harming than the carbon dioxide. Now, reducing the methane emission is a very crucial to actually handle if we have to handle the climate change. And one of the major place where the methane is generated is in the landfill, or different processes what we have, the biodigesters. So how we reduce this methane emission of methane, and just by using the enzymes. Now we'll just go through this small journey, and quickly I'll just say the problem what we would like to focus here is a methane is a potent greenhouse gas, and it's trapping the heat in the atmosphere. And the second one is the lack of oxygenation or an anaerobic condition that promotes the methane generation from the food waste. Now, how do we tackle these two issues? We'll see that. Now, we just see the food, whether we have a cooked food or we have the raw food, the processed food or the raw food. So the objective here is how do we reduce the methane gas, and how do we create a cooler and cleaner environment. The composting is one of the traditional method, and decentralized composting is possible. Yes, there are a lot to do with the behavioral changes what we see today in our society, and but it is possible, and believe me, people love it when they see the change in them. And other one is like the organic matter, which decomposes aerobically, so that doesn't generate too much of methane. The anaerobic process definitely has an issue. The aerobic process, it generates the simpler compound like carbon dioxide and water. So when we compare this composting method with bioenzyme, now bioenzyme is definitely an alternate method where the food or the waste, when we consider this as a waste, it is managing them. And it is possible to make bioenzyme from the cooked or uncooked food. And bioenzyme is a fermentation process where the oxygen is present, and the result is minimal in methane production. So whether the moment the raw material, as I said, for bioenzyme is the waste what we generate from our kitchen, and the moment we put it for fermentation, it gives that aerobic condition, or if there are presence of oxygen molecules in that, which reduces the methane. So comparatively, it is cooler than composting also. Now, what is the, these are just a hypothesis I would like to say. The bioenzyme, how does it affect environmentally? Now, unlike composting, the bioenzyme, it generates the oxygen molecule instead of methane. Now, fermentation process produces carboxylic group, fostering aerobic bacteria and aiding oxygen. Bioenzyme fermentation results in no methane generation, contributing to reducing the greenhouse. Carboxylic group facilitate aerobic decomposition, enhancing the waste breakdown. So bioenzyme has a multiple application. If we just go through each of them, it has multiple applications, and how we use it and how we can use in today's challenges what we have in the waste management is how creatively we can use it, as I can address that way. Now, principle of bioenzyme, the way it functions. The bioenzyme has a function of catalysis. It decomposes, it transforms, and it recombines. It replenishes the microbes that is originally lost in the process of whether in whatever way, whether it's a dirty water or the landfill. So it just brings back those microbes. It increases the oxygen content to make aerobic bacteria are dominant in the group and restore the ecological balance. Now, when you see this, I feel, the legacy what we have as in terms of landfill, or now the water bodies also. Now, instead of generating those methane and any other toxic gases, if it start generating oxygen and start taking care of itself, how the world will be, that actually brings the big hope in seeing how we can look at the waste management from the different perspective. How about, every landfill is generating the oxygen, or, every dirty water body is generating the oxygen. So we have done this lot of applications, but compared to the way food waste, I would like to just focus on these three. Now, landfill, what we have treated with enzyme, we have seen the drastic drop in the methane generation, and this is one of our team member in Indonesia. That's a Sumampu landfill which has been treated. It was almost 13 hectare of a huge landfill where the entire thing was treated with enzyme, and we saw the drop in the methane gas generation and other toxic gases as well. Polluted water body, we have seen the water body which is actually smelling bad, and we have treated this. Within 2 days we have seen the transformation happening. Now, the third one, what I would like to show is the leachate treatment. This leachate body is in the landfill, dump site, what we call it. And it's like it was full of, methane generation, what we could just smell it. Nobody could stand there. But today, that leachate body is in the form of irrigation quality of water. The entire black leachate which was generating the methane is of irrigation quality. The last one, the picture what you see here, that is a irrigation quality water body. So bioenzyme has definitely transformed these kind of things, and additionally it also enhances the soil fertility, the air quality through the versatile applications. We've been a lot of people in our country, we are making a lot of household products, which can improve, which at least we don't throw this toxic chemical into our water body. So they've started making enzymes at home, and they make products out of it, which doesn't pollute our water bodies and the drainage system. Now, just a closing thought, the bioenzyme presents a promised solution for mitigating the environmental impact of food waste. And by reducing the methane emission and promoting aerobic decomposition, bioenzyme contribute to sustainable waste management practices. And we have seen this happening, and definitely behavioral changes is one of the very important factor what we need to bring in. And it is possible. I live in Bangalore, so we have done some projects here saying, the entire community, every small house, or apartment or a flat, whether they have garden area or they don't have garden area, they can still do the composting without the smell and other whatever challenges people they feel it is a challenge. Making a compost, it is definitely not a challenge, and I've seen people changing the way they look at things. So this is where our bioenzyme, I can say, first it reduces it is made from the thing what we waste, and even after making enzymes, we can handle a lot of other ecological or environmental challenges what we are facing today. So I would like to conclude with this without taking much time. I wanted to be very short and sweet. I'm open for any questions if you have anything.
Thank you so much, Preeti. Thank you for keeping it short and knowledgeable. And I would like to ask the all speakers few questions which are there in the. Maybe we can just answer for 5 minutes and make it like a panel discussion. One question the Nandagopal has this: if the user behavior is sustainable, can we provide the credits to the user so that uh, can we provide the credits to the user is the question. I would like to I would like if any one of the speaker answers this
I
question.
think that's what is the aim of the thing. If you have credits, it will be credited. If you have to pay, you will have to pay. So it should be acceptable, right? Say if you are giving a resource which has value, you can take a credit. If you have a resource which is objectionable, then you will have to pay.
Yes. Thank you, sir.
Very
Thank
true.
you
We have a similar model
next
at our Jamshedpur site. We have a similar model. So it's like if you give segregated material, so the user fee that you are paying, that will be nullified, and it can be nullified as for as high as 6 months.
Yes. So yes, so the whole point is if we give some credits to the user, I think it will make them also to encourage solid waste segregation, and we can make some sustainable changes for the waste management. Next question from Shakti Ranjan Patra: how the education institutes adopt best practices for segregation or decompose the food waste in the respective campus and integrate with the housekeeping service. His question is mainly he's one Shakti ji, are you there? He's one of the person. He's one of the officer in the um, Bhubaneswar Institute. I don't know exactly the institute name. So he's asking a question that if education institutes adopt the best practices for segregation and decompose the food waste in respective campus and integrate with the household services, is his housekeeping services? It's his question, and so that can we reduce the municipal burden and use for horticulture requirement? This is his question.
I have one practice that is being practiced. Fortunately, in all of the educational institutions, maximum food waste comes from the messes, from student mess, right? So
Yes.
what happens in either NIT Warangal or in where I am right now, Nujvi, there are takers who feed pigs with the material that they take. So they collect all the food waste. So it doesn't go to the municipality. The food waste from the student mess goes to the, yeah, it is a byproduct. But actually, he doesn't pay anything for us, but he doesn't charge us. And maybe you can put an anaerobic digester, but the problem again, I think madam should answer this. Again, in summer vacation, what happens to the digester? There is no feed.
So I would like to add here. Now, when we talk about this bioenzyme, when we start making it, in the campuses, so these bioenzymes can be used by housekeepers. It can be used for treating their STP waters. It can be used as a fertilizer for their plants. So, you don't invest so much in buying those extra things from the market, and you start making the use of the waste what we get it from the kitchen or the canteen or the mess, and start using those things for the different use in the campus. And I feel this is the best thing what any institute, if they take the charge of their own waste, and they believe in it completely, that there will not be any discharge from my campus or will not be a burden to any of the corporation. It is possible, and it is definitely possible. And in this process, when we start implementing these kind of projects in the campus, the students also get more aware of things even after they are out from the campus. They know what impact it can, you're just using the few things can change so many things in our ecology.
Yeah, thank you, Preeti. Ananya, yeah, you can.
I would like to add on one more thing here. Very beautiful point given by Madam that bioenzymes could be a game changer as because it's a batch process. So the threat I was trying to highlight in biomethanation, that inconsistency of material supply. So that also can be avoided. One, it comes with a caution, that is the aerobic environment needs to be maintained throughout. Otherwise, there will be a lot of odor generation, which will be hectic for the dwellers in and around. So for that, we need to ensure that it is turned, the waste heaps, they are turned regularly. So that part also has to be, taken care of.
Thank you, Arthur. Yeah, Ananya.
Yeah, I just wanted to say that the way to engage, or rather, once you have as Sir mentioned, that the messes are typically the biggest generators of wet waste. So what can be easily done is you can take the wet waste, and if you can separate wet waste in the way that there is vegetarian wet waste and there's non-vegetarian wet waste, what you can do is you can take the vegetarian wet waste and feed it to cows, right? And the non-vegetarian wet waste can be decomposed and used for horticultural reasons, or it can be given even to the municipality. And typically we have plenty of cows and herbivorous animals across India, right? So that's an easy solution as well, along with what Sir mentioned of feeding pigs the food. Pigs are omnivorous; they eat everything, right? That's a solution as well.
So thank
Yeah,
you
in the
so much.
non-vegetarian portion, bones are actually one of the major problems. We have installed back in 2018, I guess, one biomethanation reactor for Indian Navy in Vizag. So, this Indian Navy bases, they serve a lot of non-vegetarian food. So bones had been one of the major challenges, both for fishes and chicken, for their calcium content. So they don't tend to degrade at all. And biomethanation, it cannot be degraded. Even for composting also, that will remain a challenge.
Yes, thank you everyone. Thank you so much for answering the question. And Nandagopal has one more question. Engagement of common user is required to reach significant step. Any steps or models towards it is the question.
I can try to take that question.
Yeah.
So thank you for asking that question, sir. The way to engage. So basically, if I understand what you're saying is you want to engage with the community and the citizens. The typical mechanism is that you engage through IEC and behavior change communication. Government of India under Swachh Bharat Mission allocates 15% of its budget under that. They have 3 modes of communication, which happens at a mass communication, which is typically say TV adverts and so on and so forth. There is mid communication, which is say jingles that are played by waste pickers. So if you're hearing Swachh Bharat Ka Irada early in the morning or something in a local dialect, then that. And you have interpersonal communication, wherein someone will come and try to build your capacity. The challenge is typically to build a behavior, it takes about at least 60 days of consistent nudges from a person or even from a mass media to come to you and for you to make or see any difference in your behavior. That period needs to be consistent, which requires efforts from the urban local bodies and from every person who is involved in the system. So if that can happen at a state level or a ULB level or at the central level, then we can definitely start engaging with people more and more. You can also look up some applications which exist. So for example, it's not necessarily related to solid waste. However, there is an application which is there. I don't remember the name of the application, but there's an application on the website of Mahua, which helps you showcase what are the yellow spots in a city, which is basically if there is a place where people are urinating in the open, then you can track that, and over a time the ULB can take action and help reduce such spots. It's not something that the ULB needs to do anything about. You just see someone, you just mention that this is where that activity is happening, and eventually the ULB can maybe set up a urinal there, set up a public toilet there, something along those lines. So citizens can definitely be engaged in different ways. We just need to find mechanisms to do that.
Yeah, thank
Rightly
you.
pointed out by Ananya. I would like to add on one more thing here. So jingles are like a mandate at today's date. So wherever we get into contract with any, you will be in PPP mode. So jingles for all collection vehicles, that's a secondary mode of communication, what you've rightly pointed out. So that's a mandate now for all the private players. Second thing is IC activities, what you have again rightly pointed out. IC activities are part of ISWM projects now. That's a mandate again. It might be the same vendor or the concessionaire who is doing the P&D activity, or it might be somebody else. But again, IC activities, conducting road shows and dramas, putting hoardings and then converting these yellow points, and we call it another thing which is called garbage vulnerable points. So wherever there's a dumping, or the spawn peaks, red spots, so they are actually getting converted under IC activities into selfie points. So converting those points, cleaning up, putting people coming there and taking selfies, those are all the new initiatives that had been taken care of. Also involving people through like social activities, like donation of their dry waste. These are the new kind of approaches that we are right now adopting, and we are handling on pan India basis approximately 4,000 tons a day. And I'm happy to convey that all of our projects, they have IC activities at ground level, and most of our, let's say 60 to 70% of our end users, which are typically the households, they are connected to us somehow by somehow or the other.
Yeah, thank you, Atun. Thank you so much, everyone, for patiently answering and giving it so much knowledge on how to make ourselves into a good, sustainable solid waste management. And yes, Shashi Raj has a question. Yeah, Shashi Raj.
Yeah, hi everyone, and thank you everyone. Thank you, Ananya sir, Atun sir, and respected director sir, Chandana ma'am, for just engaging us in this beautiful talk. So my question is primarily with socio-technical perspective, since I am working in CETSD department and I'm a project staff working in sustainable livelihood. So my question is with the socio-technical perspective and also with the perspective of public policy. So as far as manual rack picking is concerned, and as we have observed in every, like most of the cities as such, and that is like somewhere considered as most environmental friendly practices and sustainable practices as such. I don't know how technically I'm true. But in the midst of automation and the midst of lot of technological advancement as far as solid waste management is concerned, how beneficial, increasing or decreasing the number of rack pickers, who is also good for, segregation, waste collection, and also for the waste trading as such. So first question is that, is there any policy intervention for these rack pickers? And second, how good or how bad is it to increase or decrease the numbers in overall, function of waste management? So anyone can take the question, but preferably Ananya sir I would like to take Ananya sir. Yeah.
You can call me Anand.
Okay.
Sorry. So there is the way I would look at it is, if I leave the discussion, if you can go on mute. Thanks. Yeah. So the way I would look at it is, it's ideal if people are not engaged in manual rag picking, right? It's not from a very social and ethical perspective. It's not right for a person to do an activity where they have to go personally into the waste of someone, and it's not really well regarded by the society, right? They end up with diseases, they end up with so many challenges. If you ever meet someone and you try to shake their hands are really rough from picking up all the waste that we are throwing. One way to reduce it is something similar to what Atun was saying that if we can identify any garbage vulnerable spots, and if we can reduce garbage vulnerable spots, people will typically not go and pick up rags from garbage vulnerable spots where they are typically seen hovering around. Having said that, we have to also find mechanisms for rehabilitating them from an economic perspective, right? No, I don't think someone is doing this because they find it a pleasurable job. They're doing it because they don't have an alternative source of income. So the city and the citizens have to find a way for them to find a different alternative route. It could be through a more formal mechanism of engaging them. You could engage them as one of the city's self-help groups. You could, because they are vulnerable, right? Say today you have removed all the waste and they do not find enough income. Tomorrow this waste is back. They are going back to that practice. So it's a policy level decision that can definitely be taken by the city, that it will rehabilitate its rag pickers, right? But but sometimes cities are unable to, right? Because if they say that I will, then what is the avenue that they are going to, right? They could create mechanisms where they say a private player can only be engaged in an XYZ service, provided they onboard X number of such people and train them, right? The city will train them, the city will do whatever is required for them to do, but they should engage such people, right? So it's not a very straightforward answer, but I think it's something that is required. Thanks for the question. I
Yeah.
hope I've answered it in some parts.
Thank
Can
you,
I add
Ananya.
on something on
Actually,
top of
can
that
you?
with all of your permission?
Yes. Before that, I just wanted to add a small thing. Shashi, it's a very difficult question, because I am sure everyone will have a different perspectives. But I'm working with the Shashi. Can you mute?
Yeah, sure, ma'am.
So in Rajasthan has a typical different solid waste management, and it has a culturally different appropriateness to solid waste, which I'm working with. One of the example I just wanted to quote is Jodhpur city. Here, rack pickers are themselves saying is that please don't disturb us. So it's a socio-technical aspect when socially it is differently looked, and technically if we see their lifespan is very less. Like if we see average of their lifespan is 40 to 45 years. The maximum is 45 years. So there's a different aspect, and I am from my point I would like to say that every story has two versions: policy, technical, and social. And solutions can come up when we keep on working with them instead of giving what do you say, instant solution. Yeah, Atun, you can go ahead.
See, there are two aspects here I would like to highlight. One is when any private player comes into the picture with ULB in DVA40 program kind of thing for managing the solid waste, the first thing we try as a company try to eliminate or minimize the intervention by the rack pickers. So if you try to take out their livelihood, automatically they will oppose it. What is the kind of scenario you have been trying to highlight? But if you generate income for them, if you try to make them earn more than what they are doing right now, definitely people would be interested to do that. The only challenge is when they are working unregulated, they're working either in dump grounds, mostly in dump grounds. Let's say 90% of during the occasions they had been working in dump grounds, which are under constant burning, and automatically there is release of a lot of obnoxious gases including SOx, NOx, dioxin, fuel, and everything. So that is why what you've been trying to highlight, the lifespan of these people, they are typically less, somewhere ranging between 40 to 45 years. That is because of inhaling all these gases, coming under tremendous microbial contamination related threat. And in India, if you see, 90% of the biomedical waste is collected and treated, so 10% is still actually ending up into the dump grounds. So there is a huge possibility that they might end up getting contaminated with hepatitis B or AIDS. So those threats are always there, and the other problem is they are not at all ready to work with wearing PPEs. They feel uncomfortable wearing PPEs. I have tried to educate these people in my existing sites, taking them into payroll, but making them wear the PPEs itself is a big challenge. When my supervisors and EHS managers are not there on the site, they will not at all wear PPEs. That is why their hands are extremely rough, their skins are of different color tone and different texture. So first of all, making these people aware through different levels of counseling, making them accustomed to it, making it a habit, it's a challenge. So it's a big challenge that cannot be addressed overnight.
Yeah, thank you, Atun, and thank you so much, everyone. We are like on time, like we are going 15 minutes late, and I would like to thank everyone for joining and making this such a successful hit. And on the day of zero waste, we learned a lot from all the speakers. And I would if anybody is interested in PhDs or working together, you can always look into CETSD website. And I also would like to thank many of the social activists. I heard from Neeta that she is working a lot in the solid waste, and she's working from 22 years. People like all of us should make a community and try to make our country into zero waste. So thank you so much, and thank you everyone for joining. And if any questions or anything, you can write to me. We can always answer you guys back. And a special thanks to all the speakers for joining. Thank you so much.
Good luck to all participants.
Thank you, sir.
Just to add one more thing, we are providing community level and institute level solid waste management solutions. If somebody is interested, please feel free to write me directly. My email ID and phone number is available with Chandana.
Yeah, thank you so much. And Professor Meenu is here. Thank you, ma'am, for joining. She is the head of our CETSD.
Yeah, I would just like to thank all the speakers. It was a wonderful session, and there has been a comprehensive discussion on the different solutions for zero waste management. Respected director talked about several solutions, including imposition of fines and all, community engagement, bioenzymes, composting solutions. Everything works. I think the integration of all these technologies works well towards attaining zero waste. No one technology is useful, and therefore it was a greatly informative session, and we've learned a lot. And I thank all the speakers, and I request them to continue to assist CETSD in attaining this sustainability that we're also trying to bring in our campus. So thank you, Chandana, and thank you all the audience for attending the sessions. Thank you so much.
Thank you so much. Thank you. Thank you, everyone. We would like to keep in touch. I'll be writing the mails. Thank you so much, everyone. I'm ending the call. Thank you.
Thank you. Bye.
Thank you. Thank you, everyone. Thank you.
Thank you, Chandana, for inviting me. I forgot to thank you.
Thank you. Thank
That's
you.
the first hand information I should convey.
Yeah. Thank you, everyone.
Okay, bye-bye.
Bye, sir. Thank you so much, sir. for coming.
Thank you, Chandana.
It was pleasure knowing you, sir.
Yeah,
Chandrasekhar, sir. I meant you.
We'll see.
And of course,
We can-
Ananya, I think he left the chat already.
We'll see how we can collaborate and do something. Okay.
Oh, yeah, absolutely. My pleasure, sir. Do let me know if I could be of any favor.
Sure, sure.
Thank
Okay,
you so
bye-bye.
much. Thank you. Bye, sir.